So question 29. All right. So is everyone comfortable up through that point? Joe, you all set to go here, bud? So this question starts out in this format, log base 13 of a fraction. And the very first thing we want to do is, well, we want to take steps. As far as I can tell, I think this problem is going to take probably 2 steps. You could make a case that it should take 3. But the very first fundamental step is to do an expansion on it. And remember that this in the parentheses is a division problem. So when we expand it, it's going to expand into a subtraction problem. So it's going to expand into log base 13 of 1 minus log base 13 of 7. So fundamentally, that's step 1. Got it? Now, a lot of people went that far and then stopped. And it was interesting to see, like, you could really tell who checked their answers with my answer key on Canvas and who didn't. And I'm not going to use names, but one person in particular, I could tell. I remember actually answering questions for one person, and it really paid dividends in these problems because I was like, that's a dude that checked his answers and wanted to know why they didn't match. So good on you. This is not the final answer. Part of this is that we also have to simplify. And that means if I see math that I can do, I'm going to do it. Do you guys all know what log base 13 of 1 equals? Yeah, one thing that we, again, I know have in our notes is that any logarithm, I don't care what the base is, any logarithm with an argument of 0 or 1 is a 0. The answer is 0. So what this becomes now is 0 minus log base 13 of 7. Any log with an argument of 1 is 0. Any log with an argument of 1 equals 0. And you think about like any other math test, if you were doing a math test and your answer came out to 0 minus 10, you wouldn't leave it as 0 minus 10. You would, of course, just put negative 10. By the same logic, I would get rid of the 0, and my final answer should have been negative log base 13 of 7. So we expand it and then simplify it out. It's kind of the way that works. So good job. I'm not here to lecture. You should be disappointed. Like if you checked your answer key, you should be disappointed that you didn't take the time to want to know why yours didn't match. So, and I would never feel differently than that. Question 30 starts out as a log of a bunch of stuff. So I got log base 3 of, there's 4 things basically inside the parentheses. There's an 8. What else is there? There's an x, right? I don't want to write x with I want to write them with an exponent. What would x's exponent be? 1/2. So I'm going to write times x to the 1/2 power. I'm just changing it because I know that that's what I should do. And I'm going to change y. What would y's exponent be? Yeah, anything that's square rooted has an exponent of 1/2, 1/2. And what is z's exponent? Right. So I didn't show this much work on my answer key because I didn't need to or want to. But when we're in the phase where we might be someone who would miss this problem, not a bad idea. Takes like 10 seconds. And now we're going to do the full expansion. So here it goes. Everyone's going to get their own log. I'm going to color code this for your educational convenience. This H says, I want my own log. And he gets his own log. I'm like, there you go. Happy now? And then X says, I'd like my own log too. And I say, okay, you can have your own log. So I'm going to give you your own log. It's like a bunch of little spoiled brats, huh? And then Y says, I want my own log. And I say, okay, you can have your own too. Log base 3 of y to the 1/2. And of course, Z's like, well, don't leave me out, you know? So we put plus log base 3 of Z to the 1/2. And again, full disclosure, I didn't show this step because I didn't need to, but this is what it looks like when there's one step to go. So I see a whole bunch of things. Let's talk about red guy first. What is red guy? Z anything? Is there any exponent that you can put on 3 that makes 8? I don't think so. So red guy says, I'm going to be a part of your answer. You can't simplify me. You can't manipulate me. I'm just who I am. Tell me about yellow guy. Bring down the 1/2. That's part of the expansion process. So I'm going to bring down the 1/2 and multiply it by log base 3 of x. And of course, green guy and blue guy are going to follow suit. And as absolutely anticlimactic and unexciting as that is, final answer. Any questions about that? That is a full, massively annoying expansion. The more of these problems you do, you start to learn that when you start writing your answer, you don't start 2 inches from the side of the paper. You start realizing this one's going to take up some real estate. So you start writing like 4 inches off to the left because you know some of you figured it out and then just carried on the next line, which that's fine too. Any questions at all so far? Between yesterday and today, we have now officially gone over every single question on the quiz. And I hope you're feeling better today than you were. Are you raising your hand or are you just, what's up? No. Nope. Zero chance. So what we're going to do now is we're going to do some practice problems. I've just kind of written them to be similar to these. I would like you to get out some paper and I'd like you to be a part of this. Don't be the silent hoper, you know. And remember, let's spread the wealth out. Let's kind of take turns answering questions here. Lauren will get a shot. Dugan will get a shot. Joe's going to answer some. Perez, everyone's going to take a shot. We'll kind of cycle around the room here. So. So I say I probably have 15 problems on here. I don't really have any idea as to whether or not that's a reasonable expectation, but I'm going to just put them up on the board and some of them will take us probably 15 seconds and some of them will take us a few minutes. And so let's get started. So these again are just practice problems. Since you have to retake this quiz, let's see where we're at. Let's see if we're ready. So basics first. Dugan? Yes. Excellent work, Dugan. The base of that logarithm is an invisible 10, and you simply just count zeros on powers of 10. Nice work. Right. Next one I have for you is log base 6 of 1. Alyssa? 0. Good. I think I've said it 4 times, maybe 5. I'd have to watch the recording, but I remember 10 minutes ago literally just saying it like a robot. Any logarithm with an argument of 1 is 0. It's the only way to turn something into 1 is to raise it to the power of 0. So next one I have for you is, again, just a basics sort of question. You definitely want to use your resources for problems like this. These are a little bit less mental mathy. Like there's no way you used any resources for the first 2. But this one, Jared, it is 3. You have a piece of paper somewhere that tells you that 9 to the 3rd power is 729. And so that's really what the math question is. How many 9s do I need to make 729, right? How about this one? This is the natural log of E, Joe. Nice job, man. That's one of those, like I call it a redundant log. The other redundant log that you're going to see is this one. Again, the answer is 1. Because the base and the argument, when they match, that means that you apply an exponent of 1 to get it to effectively not change. So watch out for those. They'll be in the first section and they'll pop up again later in the expansion section, and you need to know how to deal with those guys. And other sorts of redundant logs, they don't have to be natural logs and logs of 10. Another redundant log could be like log base 81 of 81, right? Anytime the base and the argument match, the answer is 1. So those are all examples of, again, I don't know that they're actually called redundant logs, but it sure feels like they should be. So, all right, can I scroll up? Do we all have these down? Okay, how about this one? What's the natural log of e to the 10th? Lauren? Good job, Lauren. Way to go. That's a log with a base of e. Good job. Not quite redundant, but pretty close. How about this one? You guys are doing a great job, by the way, of getting around the room. Every one of you so has almost volunteered an answer. I'm really proud of that. Thank you for that. So let's do log base 4 of 1 over 256. Alyssa? Correct. Coming into this, the first thing you know, come hell or high water, is that this answer is a negative. Is the only way I'm going to make it a fraction, is to give it a negative power. So first thing I would write down if I were taking my own test is I'd put negative before I forget. And then I would just go to my power table and look and say, how many 4s do I need to make 256? The answer is 4. So negative 4. How about this one? Log base 11 of the 4th root of 11. This is one where you really shouldn't have to show work for the record. Brady? It is 1/4. Nice job. Let's all remember that what this Goldilocks would have been if you wanted to show work would have been, okay, I need to convert that. When I see radicals, I ought to think about converting them if I'm not sure. The Goldilocks would have been 11 to the power of 1/4. And then it becomes one of those borderline redundant sort of issues. Any questions there? That concludes to me what would be like the warm-up section. Any questions at all? Okay, on my note card, I have these more as like a level 2 set of problems. So let's work through these and see if you have any questions. So for the first one, I have log base 81 of 243. It gets a little more real, right? Like it's like you go from first gear to like third gear. Okay. You just skip a level. Uh-huh. How did you get that? Let's see if it's 5/4 or 4/5, but I can tell you that you're correct. So well done, Lauren. Let's go through this full process. Um, I'm going to set it equal to x, and I'm going to do my thing. So here it goes. I'm going to say that 81 to the power of x is equal to 243. And like Lauren said, excellent, just super quick observation. 81 and 243 are both powers of 3. That's the best we can do with those two numbers. What is 81, did you say, Lauren? Nice job. So this left side is 3 to the 4x. And what is 243? Nice job. And just like that, Lauren was real super quick to get operation match the base completed. And then just make sure, my only apprehension with how quick she did that, when, by the way, great job, is that 4/5 and 5/4, it's pretty easy to get those backwards. So just be careful, right? It's good to go fast and be awesome, but just be careful. But yeah, in this case, 4x equals 5, right? And so divide both sides by 4. And again, Brannigan. That was really fast. Well played. Well played. Any questions on that? Okay. Let's go again. We're still kind of in level 2 here. Let's do log base 125 of 1 over 25. I'll never veer off course. Like when I do these, I just won't ever do these differently than this. I'm going to set it equal to x. Brady, what'd you get? You got 3 halves. Is that what you said? Okay. Are there any other answers? You got negative 2/3. Okay. So, so this is, listen, I'm not, I almost, obviously only one of those can be right, right? And maybe they're all wrong because there's another variation of this, isn't there? There's another one that we're missing, and that's, of course, 2/3. So can we, I think we can see how easy it is. Like Lauren proved it that last time, how quickly she came up with those numbers 5 and 4. It was like instantaneous. And so at that point, we've done enough of this to realize the answer is going to have a 5 and a 4, right? And like you guys know that 5 to the third is 125 and 5 to the second is 25. So we know our answer is going to have a 2 and a 3. But what we have up here on the television is literally every possible fraction built out of 2s and 3s, right? And only one of them can be correct. So let's work this through. I'm going to water cycle it out, and I'm going to put 125 to the power of x equals 1 over 25. And now all I need to do is play that Goldilocks game and say, okay, 125, what are you? What is 125? Yes, he is non-negotiably 5 to the third. And then I'm going to stick the x on that side. What is 1 over 25? Nice job. He is 5 to the negative second. And at this point, if we play our game of operation match the base, it's like we're done. I just say, well, logically now, 3x has to equal negative 2. Be very careful. Remember, you're dividing both sides by 3, and the answer then pops up, negative 2/3. You see how quick it can happen. Again, you know the answer is going to have a 3 and a 2. Showing that little extra bit of work is what ensures that we don't put the wrong number in the wrong place. Good. Good, good. Jared, you good? Okay. The last one I had for level 2 is log base 16 of the 5th root of 128. I think I said it yesterday, and I would say it again. In my opinion, this is one of the harder questions on the quiz. These are struggle questions that you got to really hold true to the process. Set it equal to x, water cycle it out, operation match the base, then solve the equation. This guy's a tough one. Any answers? No. Sure. So you think you got to a good point and then hit a wall? Nice job. Yeah, that's going to be a big step for us. Listen, if someone said to me, like, all right, you get one shot to teach this to a room full of kids, give it your best, give it your A game, because if you don't do well, like I'm stealing your house or something like that. Or, I mean, what I'm trying to say is if I had to bet the mortgage on one way to teach this, it's what I'm about to show you and what I've shown you every single time we've done one of these. I'll never veer. Step 1, I'm going to set it equal to x. Step 2, I'm going to water cycle it out. I'm not going to do any math yet. Okay, I'm just going to leave it nice and pure. I don't want to lose anybody. So 16 up to the power of x equals the 5th root of 128. Like I didn't do anything. I just cycled it out. The next step is to operation match the base this thing. So let's talk about the number 16. What is 16? So I feel like the left side is pretty well. I'm content with the left side. He's looking pretty solid and ready for the last step, right? Now let's head in here and let's talk about the number, only the number, please, that I'm putting in the gold box. What is 128? Nice job. He's 2 to the 7th. And so I'm going to, through the power of my digital eraser, I'm going to erase the number 128. And in his stead, I'm going to put the number 2 to the 7th, because now I can bring down the, like the opponent, if you, I don't know how you say that, but like the other side of the equal sign that's now going to go into the little game. So what is going to come down over here? 2 to the what? 7/5. You okay? Everybody okay? And now this is a good place to get stuck, because there is some annoying algebra that we have to do at the end. Now that all the cool manipulation stuff is over, now we just have to say, hey, red guy, I need you to go equal that red guy. Because as I said before, if the bases are the same and they equal each other, then powers have to be the same. So here goes, a little basic algebra. 4 times x equals 7/5. How do you solve that equation? Divide both sides by 4. So when you have 4 times x equals a number, to get rid of the 4 that's on the x, we have to divide both sides by 4, right? And if I cancel out these 4s, I'm done. And this just keeps coming up. And as I know from experience, if you try to teach something to 50 kids, like 17 of them get it the first try, 9 get it on the second try, and then that 50th kid gets it the 83rd time you go over it. So let me ask again. When you have to take a fraction and divide it by a whole number, what really do? You multiply the bottom number by what you're dividing by. It's just common sense. If you divide something by 4, it gets 4 times smaller. And how you make something smaller is by making the bottom of the fraction bigger. And so if you take the bottom of that fraction and multiply it by 4, your answer should have been 7/20. Good. So that's a toughie. There's just, you don't work around and shortcut something like that. I wouldn't. Just do the steps. All right, we good there? All right, I'm gonna flip my note card over. The rest of this is the stuff that would have been on the back page of your quiz. And honestly, I didn't write any bottom ones, but I have a ton of equations because I know you guys don't much care a person with those. So let me just run down the list of what I have, and let's just keep doing the same game. Spread it around, raise your hand if you want. Let's all answer questions. So first one I have is a very simple equation. I have log base x of 64 equals 3. This just boils down fundamentally to how well do you understand the relationship between the logarithmic version of an equation and the exponential version of the equation. Water cycling, remember, turns it from one end to the other. Jared, what'd you come up with, bro? I agree with you. So if you cycle this out, you just get x to the power of 3 is 64. And you don't need any real heavy weaponry for this. You just look either in your brain, if you've memorized this, or on a resource like a piece of paper, and you say, what number, if I raised it to the third, equals 64? And the answer is 4. So that's that. Next one I have, I would also call this more of kind of a warm-up-y sort of equation. I have log base 2 of x equals 9. You got this one? What is it? That is? It is 512. If you correctly water cycle this out, it would look, let me draw another little water cycle because I like every chance I get to do this. Follow the blue arrows. 2, to the power of 9 equals x. So we don't really have any algebra to do per se. The equation's already got x by itself. We're just gonna, I saw you guys with your fingers looking on your charts. 2 to the 9th power is a lot of 2's. It makes 512. You good on that one? Okay. Next one I have is log base 11 of 1 over 121 equals x. Correct. If I cycle this up and out, I'm going to say that 11 raised to some unknown power has to equal 1 over 121. And, we've done enough of this to know now what's being asked of me. I'm being asked to find an exponent. The one thing we know for sure about our exponent is that it has to be a negative, right? That's the only way 11 is going to flippy flop down to become 1 over something. And then you just say, how many 11s do I need to make a 121? 2. Any questions on that? Brady, you good? Okay. The two most offensive answers that you could give me, number one would be negative 50. That one would make me want to say some pretty dirty words. And then secondarily, like in second place on the offensive race would be negative 10. Those answers both hurt me on a very deep level because remember that negative exponents do not make negative answers. Don't forget that. Brady? It would be 1 over 10. Let's take a look at the process. This is another one where you don't really have to do anything to get x by itself. It just sort of naturally pops out that way. But if I water cycle this out, I start out by saying, okay, so 100, if I raise you to the power of negative 1/2, I get x. And so again, the xy part is done. I just got to do the math. The negative exponent barks a very direct order at you. He says, I need you to do one thing. I need you to take yourself, Mr. 100, you and your cute little exponent, and I need you to move downstairs. That's all he does. And what does it mean when someone asks you to raise something to the power of 1/2? It means to take the second root, the square root. And we all, without any charts, we know the square root of 100 is 10. So that's why x is 1/10. Good. How about log base 64 of x equals 5/6? Haven't heard from Dugan in a while. Haven't heard from Joe, Perez, Lauren. I guess I heard from you somewhat recently. So 64 to the power of 5 over 6 equals x. I love that step. And I like especially these ones where when you water cycle it, it just says equals x, because that tells me that I don't have to do any real algebra. You know what I mean? I don't have to raised both sides to a power, or it's just done. Like I just got to do the math, right? Brady, it would be 32 on the nose. Let's talk about this. And anytime a fractional exponent pops up, I need to just keep repeating myself until you get this stuck in your head. Each part of the fractional exponent has a job to do. It will never change. Red guy, what's his job? Has always been, always will be. Dugan, what's that guy's job? He makes a root. Anytime you raise something to an exponent, if the exponent is a fraction, the bottom 100% of the time does the same job. He says, make a root with me as the root type. Got it? He says, go make a sixth root. And you say, yes, sir. Now, Dugan, do you remember yellow guy's job? He does. He's a power, right? And this, again, I'm telling you, I like it in math when I can say the word always. It's always true. Bottom guy has a job and it's always the same. Top guy has a job and it's always the same. And now the only thing left to do here is just take the number, the 64, plug it in, and let's hope that we can use our resources. You have power tables, exponent tables. You have some that you maybe put into your notes. You have that whole piece of paper. Endless possibilities. Do you know what the sixth root of 64 is? It is 2. It's on your table somewhere. And if it's not, add it in your notes. And then you take that yellow exponent 5, you drag it down. What is 2 to the 5th? And that is where the 32 comes from. Good there? Feeling good? You sure? Okay. Log base x of 1 over 27 equals -3/5. After this one, I have 3 more equations, and then we can dabble with anything on that bottom section as you wish. We're clearly not in the warm-up section anymore, right? This isn't fudge your way through it. We've left the I kind of know what I'm doing zone, right? I haven't heard from you in a while, Alyssa. Um, nope. Brady. I believe it is 243. And I'm doing this in my head. I haven't actually worked these out yet, but I think that seems more like in line with what I wanted us to get. This is up there. If we were playing like Rock Band or Guitar Hero, this would not be one of those songs that has like 2 stars next to it, right? This is one of the 5 stars. This is a much harder problem. This is where we really separate the who's going to follow directions to the letter versus who's not. So here it goes. Step 1 is to cycle it out. If I haven't made that point clear by now, I am in line as the worst teacher of the year. This has to be water cycled out. So x raised to the power of -3/5 equals 1/27. How do we get x? This is an algebra problem. This is not one that just popped out equals x. This is like, okay, I got to do some algebra to get x by himself. Right. And remember, be careful. And I know exactly what you mean, but we're not actually multiplying both sides. We're actually raising both sides to the power of -5/3. And I know what you mean, because this blue box, yes, turns out to be a multiplication problem, but it happens because we're exponentiating, not multiplying. And again, I don't have any gray area here, like, gosh, well, what would I do if this or what? There is no, it is what it is. When you have x to the some power, if you can do it in your head, great. But in problems like this, yeah, don't think so. So whatever that exponent is, just flip it over and use it as a new exponent. Just flip it and use it, flip it and use it. Every time it'll work because that's what reciprocals do. They cancel each other. And that's what we're trying to do. So I'm going to scribble out these exponents here. And I'm going to say that the algebra portion of this problem is now officially over because done. Got to do math. And again, I feel like I can be as deliberate as I want, but until you're really ready to listen, you're not going to hear this. That exponent has to be done in 3 steps. 3. Here we go. First, yellow step. What one thing only does that negative sign mean? What does a negative exponent do? It starts with an F. It flips things, flips, flips, flips. It's literally his only job. That negative sign leads a very boring and quick life. He has one job. Boop, I'm going to flip the number over and I'm out. Peace. So the next thing I'm going to write is the flipped version of 1 over 27, which is 27. And I'm going to give it a brand new exponent without a negative because the negative spent himself. It's just all negative exponents do. Next in line, Dugan, I'm coming back to you and you know why. What is this 3's job? You're going to make a cube root. Attaboy. So that I'm just going to follow orders says to make a cube root. And Dugan, I'm coming back to you again. What does this blue number mean? Yes. Fractional exponents are predictably repetitive. Bottom goes to the root, top goes to the outside power, and then you just slap the 27 inside and hope and pray to God you can do some basic math. What is the cube root of 27? 3. What is 3 to the 5th? Or was? It's a tough problem, but I'm trying my best to make it as manageable by just showing you never veering off course. Do this, then this, then this, then this. It'll never change. Let's do some more equations. Let's do log base 8 of 4x minus log base 8 of 5 equals 2. I just called an audible and just wrote this one because I realized we should have one like this. So this is kind of a warm-up-y thing. What's your brain immediately tell you to do? Condense. Can we? We can, because there are no blockers. And in case you don't know yet what I mean by that, I mean there is no number right there, and there is no number right there. So if there are, you got to clear those guys out. Hint, hint, foreshadowing, next problem. But for this one, no blockers means let's just dive in. So you condense into one singular log, and this new log, what will I do with these yellow things? I will divide them because that's what minus tells me to do. So in my new argument, and I don't actually divide them. I don't put like 0.8x or some nonsense. I just leave it as 4x over 5. Brady, what else? What do we do next?
Next, you would
Water cycle it out. 8 to the power of 2 equals 4x over 5. Next step, multiply both sides by 5. Next step, divide by 4. And of course, you'd want to go back and verify that 80 is okay, but you can clearly see that 80 is going to cause no disruptions to the math gods here. Questions there? Next one. What do we want to do? Right. I mean, I'm glad if that's actually, I mean, we should want to condense, right? But we got to get rid of the blocker. And the 3 says, hey, you can't condense with me here, nanny, nanny, boo boo. Ha ha ha. But we're like, we're not, we got you, bud. So we're going to leave the first log alone. And we're going to shoot that 3 with the red arrow pointing to it. Follow the little yellow arrow here. We're going to take him and go, put him right there. That's what happens with logs is you can shoot things up to powers and back down, up and down. Whatever occasion suits your, whatever suits your occasion. So I'm going to rewrite this now as minus log base 6 of 8. Because that's 2 to the 3rd. Now what are we going to do? It's time to condense. And when I condense, I will use division, multiplication. Division, and I won't actually divide it. Remember, I will just express it as a fraction. Next up. And for the record, if you wanted to reduce right now, the 6 and the 8, you could. But I will do as I was told. Let's water cycle it out. Anytime you get it down to a single log equals a number, just don't even ask, just cycle it. What's what we want you to do. It's what the math gods, not me, what they want you to do. 6 up to the 3rd is 216. You did reduce it? Yeah, right. I was thinking I might, so I hope everyone is comfortable if I do that. Instead of writing 6x over 8, I hope you wrote 3x over 4. Good. It's a good move. I always feel like reducing earlier improves our chances of reducing correctly later. So nice. What do we do next? Multiply both sides by 4, which gives you 864, I think, equals 3x. And then you divide by, say it again. 5 by 3. Yeah, I heard all that. It's just that last number you faded, 288. Nice. Again, go back and check it and make sure you're not going to break any rules. And you're like, yeah, you're fine. Not going to break any rules. Okay. Next one. Log base 6 of 2x minus 3 plus, you know where this is headed, plus log base 6 of 3x minus 2 equals 0. What do we want to do? Can we? Let's do it. Let's condense. Are we condensing into times or divide? Times. In case you're a little wondering, what do we mean? What is happening around me? I have no idea. That means to take this yellow thing and this yellow thing, and you go all algebra 1 on those suckers. You'll multiply them together. You're going to do it right. So when I multiply them together, I get 6x squared minus 13x plus 6. And that's just, I always skip steps and then I find myself going back. I always wonder, like, why do I skip it only to go back and show how I got it? So that's just me doing the 4-step process. So, like, what is 2x times 3x? 6x squared. What is negative 3 times negative 2? Positive 6. And then, of course, in the middle, I did minus 9x minus 4x, right? Hopefully, we're like past that point where that's even an issue. Fingers crossed. Next step. Can't factor yet. It's not a solvable equation right now. It's a logarithmic equation. We do not solve logarithmic equations. We convert them to other types of equations so that we can solve them. Say it again. 100% of the time, yes. That's 6x squared minus 13x plus 6. He's off limits. He's like, hey, I'm busy. I am trapped in a log right now. If you want to play with me, fine, but you better get me out of here. And the only way to do that is to convert this to an exponential equation. For the 147th time, probably in the last 2 weeks, let's water cycle it out. The base is 6. What is 6 raised up to the power of 0? It is 1. You ask that with a questioning tone, that should be 100% take it to the bank. Smack dab forefront in your notes. Anything raised to the power of 0 is 1. And at this point, we've officially left the land of logarithms. We just passed the sign that said you are now leaving Logarithmville, and now it's just back to solving a quadratic equation. What do we do next? Subtract 1, giving us 6x squared minus 13x plus 5. Did you factor it? What'd you get? X plus 5. That looks correct. Good job. Well played. And we're not out of the woods yet. You get a lot of points if you get this far, but you're not out of the woods. Now we have to figure out what our answers are. From this first set of parentheses comes the answer candidate. We'll call him 5/3. From this second answer, for the second set of parentheses, we get 1/2. They are naked answers right now. They're just out there. They're waiting for us to show the world that we've either committed to them being good or committed to them being bad. We do not want to be rude and leave it up to the reader to decide. We commit. How do we find out? Plug them back in. Let's start with 5/3, the red guy. So if I take 5/3, that's like 1.7-ish, and I go back and I put that in. If you grab a calculator and you multiply like 2 by 1.7 and take away 3, and then 3 by 1.7 and take away 2, you'll see that those both come out to positive numbers. And for that reason alone, you say x equals 5/3. I got you a little something. Have a box. A little something, something for you. And then we go the green guy, we take a half and we go back and we plug it back in. I'll go all the way back to the beginning of the problem, and it doesn't take long. Look where this green arrow is pointing, right there. What is 2 times 1/2? 1. What is 1 minus 3? No bueno. So I go down and I also say now to x equals 1/2, you say, hey, bro, I got you a little something, something too. A little cross for you. Okay. Remember, leave no naked answers, please. There's more, but let me give you a couple of minutes just real quickly. Are there any of the problems in the last section that you guys did, those last 6 problems, that you feel like you need to talk about more? The expansions? Hmm? I'm talking about questions 13 through 18 on your quiz, bro. The last section of your quiz. Are there any questions in that expansion section that you feel like you need more work on? Okay. Other than one equation that I didn't have time to get to, I think we did a good job. I will put my last practice problem up here. You don't have to do it. This would just be optional for someone who feels like I really need the practice. So here you go. And if you wanted to work it out and come back and check it with me, or work it out and then put it into photo math and see how you did, either way, that's completely up to you. I'd say we got pretty far today, so that is that. You feel good, Joe? Right on.